My name is Paloma Sodi, and today I'll be discussing our work on learning tactile models for factor graph-based estimation. Our goal is to estimate latent object poses given a stream of tactile image measurements for manipulation tasks such as planar pushing. We solve this by learning tactile observation models, which in turn integrate as factors within a factor graph during inference. So what is this observation model? It's the likelihood of states x given measurements z, which we express as a quadratic objective under Gaussian assumptions. Now, instead of learning a direct mapping from image measurements to poses or states x, which is hard, our key insight is to predict relative sensor poses about the contact point from a pair of tactile images. We do this by featurizing each image and learning a mapping from the displacement of features between the two images to the relative object pose about the point of contact. These predictions then get incorporated as relative factors between non-sequential poses in the graph, which in turn correct for accumulated drift in the object pose estimates. And now, in addition to the tactile predictions, we also incorporate engineered physics and geometric model priors into the graph. We evaluate our approach for tracking object poses during planar pushing tasks. This is the overall experimental setup with close-ups on the motion capture, the object, the end effector, and the digit tactile sensor. Now here's an example of a typical planar pushing trial with a rectangular object. The top left shows the tactile image from the digit sensor. Now as the object is being pushed, we can see that the contact patch in the image moves around. We collect several such trials, pushing 3 objects over varying trajectories. Here we see that the key point features learned on these images track the contact patch in the tactile images. Notably, different objects create different local contact patches. Let's look at the final task performance on object tracking. On the left, we have the learned relative tactile factors, and on the right, we have results using only a contact detector, which is the information one gets from a binary contact sensor. For this trajectory, the contact detector only estimates on the right drift enough so that it localizes about a completely wrong contact point once we make and break contact. Here are some results for 5 different trials pushing a rectangular object. We see that our learned tactile approach is able to reliably track the object poses over time, recovering the poses close to their true trajectory and matching oracle performance closely. Here are more results for different object shapes, a circle and an ellipse. Please check out our paper for more details and discussion. Thank you for your time.